The Earth. The miracle planet. Earth is the third planet from the Sun, and the only known place in the universe to harbor life. It is a terrestrial planet, with a surface about 70% covered by liquid water, a nitrogen-oxygen atmosphere, and one moon. Earth rotates on its axis approximately every 24 hours, creating day and night, and orbits the Sun once every 365.25 days, resulting in 1 year. Earth is an oblate spheroid, meaning it is a sphere that is slightly flattened at the poles and bulges at the equator, and it's a rocky planet with a crust, mantle, and a core made of solid iron and nickel. The crust is made of tectonic plates that move and cause geological events like earthquakes and volcanic eruptions. Earth is approximately 4.5 billion years old. The name Earth is derived from the Old English word for ground or soil. Historically, other names have been used, including the Latin name Terra and the Greek name Gaia. As I mentioned earlier, Earth is the third planet from the Sun. The average distance from the Sun to Earth is about 93 million miles, or 150 million kilometers, though this distance changes because Earth's orbit is elliptical. This average distance is also defined as 1 astronomical unit. Light from the Sun takes approximately 8 minutes and 19 seconds to reach Earth. There is an interesting theory regarding the formation of our solar system and the planets. After the Big Bang, a nearby supernova may have compressed a vast cloud of gas and dust, causing it to spin and collapse into a solar nebula. The center of the nebula became the Sun, while the remaining material in a disk, known as the solar nebula, began to clump together into larger masses. These clumps, called planetesimals, collided and merged in a process called accretion, which gradually built up the planets. The early Earth was a molten ball of rock. Heavy elements like iron and nickel sank to the center, forming the core, while lighter materials rose to the surface. This process is called differentiation. A massive collision with a Mars-sized planet called Theia is the leading theory for the Moon's formation. This impact ejected a huge amount of molten rock, gas, and dust into orbit, which eventually coalesced to form the Moon. After the initial bombardment of impacts subsided, the Earth's surface began to cool, allowing the oceans to form from water released by volcanoes and from impacts from icy comets and asteroids. Over time, volcanic outgassing released gases into the atmosphere. Later, the appearance of cyanobacteria producing oxygen helped shape the atmosphere we have today. Scientists think Earth formed in 3 different stages. The first stage is known as accretion. Particles within the solar system crashed into each other and stuck together, forming larger and larger bodies. During the next stage, a protoplanet crashed into the very young planet Earth. This collision is thought to have occurred more than 4.5 billion years ago. It might have resulted in the formation of Earth's moon. The final stage of development saw the bombardment of the planet with asteroids. Scientists think the asteroids that slammed into Earth, the Moon, and other inner planets contained a significant amount of water in their minerals. The asteroids hit the surface of Earth at a great speed, shattered, and melted. Experiments suggest nearly 30% of the water in the asteroids could have remained on Earth. All of these contributed to the formation of life and making the Earth the miracle planet in the universe. Earth's composition is layered, beginning with a solid, rocky crust on the outside, followed by a thick, hot mantle made of dense rock. At the planet's center are the inner and outer cores, both primarily composed of iron and nickel. The inner core is a solid ball, while the outer core is a liquid layer. The Earth's crust is the outermost layer of the planet, consists of two main types: thinner, denser oceanic crust, and thicker, less dense continental crust. This dynamic layer is the source of earthquakes and volcanic activity, and contains the majority of the Earth's natural resources, like metallic ores and hydrocarbons. The Earth's mantle is between the crust and the core that makes up about 84% of the planet's volume. It is composed mainly of silicon, oxygen, and magnesium, and is divided into an upper and lower section, with the upper mantle being more plastic, and the lower mantle being hotter and denser. The mantle's slow convection drives tectonic plate movement, which causes volcanoes and earthquakes. The Earth's core is its innermost part, made of a solid inner core and a liquid outer core. It generates Earth's protective magnetic field through the movement of the molten outer core, which is crucial for life, by shielding the planet from solar radiation. The surface of the Earth, or crust, is made of land and ocean floor. Approximately 70.8% of the surface is covered by water, while the remaining 29.2% is land. This dynamic surface includes everything from continents and oceans to the atmosphere, water, and all living things, and is constantly being reshaped by geological and atmospheric processes like tectonic plate movements, erosion, weathering, volcanic activity, movement of glaciers, flooding, meteorite impacts, growth of coral reefs, and other processes. The crust varies in thickness, being thicker under continents and thinner under the oceans. The land includes varied terrains like mountains, plains, and deserts. The water includes oceans, which contain both international and territorial waters. The biosphere includes all living organisms on the planet. The Earth's atmosphere is a layer of gases surrounding the planet, held in place by gravity, and composed mainly of nitrogen 78% and oxygen 21%, with smaller amounts of argon, carbon dioxide, and other gases. It plays a vital role in supporting life by regulating temperature, shielding the surface from harmful solar radiation, and providing the air we breathe. Foreign impacts on Earth refer to how celestial bodies like asteroids and comets have impacted the Earth, shaping its geology and the evolution of life, and include both physical effects like craters and potential for delivering organic molecules. Recent impacts like the Chelyabinsk event also demonstrate that these events are not purely historical. Impacts have created large craters, such as the Chicxulub crater, which is associated with the extinction of the dinosaurs. Other examples include the Nordlinger Rise in Germany and the Manicouagan Reservoir in Quebec. Large impacts eject thousands of tons of material into the atmosphere and space, altering the local and global environment, and cause of mass extinctions. Impacts can cause massive explosions, shockwaves that shatter windows, tsunamis, and earthquakes. Large impacts can trigger catastrophic events, like firestorms, and have long-term effects on the environment. The impact that created the Chicxulub crater is believed to have caused the extinction of 50% of life on Earth at the time. Impacts are thought to have delivered or generated the building blocks for life, playing a crucial role in its origin and development. Impacts can also create new habitats, such as crater lakes and hydrothermal systems, which can support life. Pangaea, in early geologic time, a supercontinent that incorporated almost all the land masses on Earth. Pangaea was surrounded by a global ocean called Panthalassa, and it was fully assembled by the early Permian epoch, some 299 million to about 273 million years ago. Pangaea was a supercontinent that existed from approximately 270 to 200 million years ago, comprising all of Earth's present-day landmasses. Its existence is supported by evidence, such as the way continental coastlines fit together, similar fossil and geological formations found across continents, and is explained by the theory of plate tectonics, which describes how the supercontinent eventually broke apart. This breakup, which began with the formation of rift valleys and new ocean basins like the Atlantic, created the continental configuration we see today. Panthalassa was the vast, ancient ocean that surrounded the supercontinent Pangaea during the late Paleozoic and early Mesozoic eras, meaning all sea in Greek. This superocean was the predecessor to the modern Pacific Ocean, and its breakup was a key factor in the eventual formation of the Earth's current continents. The unique conditions within Panthalassa, such as its large size and unique oceanographic patterns, played a significant role in shaping marine ecosystems and influencing the evolution of life. It existed from roughly 335 million years ago until Pangaea began to break apart about 230 million years ago. Earth's geography is characterized by a water-covered surface and a diverse landforms on its remaining landmass, and a dynamic internal structure of a solid inner core, liquid outer core, mantle, and crust. Earth's outer layer, the lithosphere, is divided into tectonic plates that move, shaping the surface by creating mountains, volcanoes, and causing earthquakes. Human activity is also a significant geographical factor, with extensive modification of the surface, while climate change is leading to impacts like rising sea levels and shrinking glaciers. After the split of landmass, Pangaea, Earth's geographical structure, went through several changes, and currently Earth has 7 continents and 5 oceans as per the most widely taught model. Earth also has over 50 named seas and around 97 bodies of water, identified as seas by the International Hydrographic Organization. 7 continents named as Africa, Antarctica, Asia, Australia, Europe, North America, and South America, and 5 oceans named as the Pacific, Atlantic, Indian, Antarctic, and Arctic. The largest continent is Asia, and the largest ocean is the Pacific Ocean, while the smallest continent is Australia, and the smallest ocean is the Arctic Ocean. The evolution of life began with single-celled organisms, evolving over billions of years through natural selection and genetic changes. Life possibly originated in hot springs or deep-sea hydrothermal vents, where simple organic molecules could form and be protected. A single lineage of microscopic organisms is believed to be the ancestor from which all subsequent life evolved. Early life forms were prokaryotes like bacteria. The development of photosynthesis by cyanobacteria began to release oxygen into the atmosphere, caused changes in the atmosphere, and paved the way for more complex life. The first eukaryotic cells with a nucleus and organelles, supported the development of multicellular organisms and allowed the specialization of cells and tissues. With natural selection process, organisms with traits suited to their environment survived and reproduced. Mutation, or random changes in an organism's DNA, provided the raw material for evolution, introduced new traits. Gene flow, or the movement of genes between populations through migration and sexual reproduction, also contributes to evolutionary changes. Over millions of years, evolution led to a vast diversification of life, with new species evolving from older ones. The living refers to all living organisms and the complex system of interactions between them. It is characterized by features like cellular organization, metabolism, growth, reproduction, and the ability to respond to stimuli. All living things are made of one or more cells, the basic units of life. Organisms carry out biochemical reactions like digestion and respiration to maintain life and obtain energy, and grow through processes like cell division and enlargement. All organisms can reproduce to create new individuals of their kind, and living things can sense and react to changes in their internal and external environments. Over time, organisms develop adaptations to help them survive and thrive in their environment. The most developed living organism are the humans, who evolved in a way that no other living beings are able to. But, at the same time, the primary threats to the living world, both the biodiversity and ecosystems, are driven by human activities, and some of them are deforestation, overexploitation for resources, pollution, and introduction of non-native species. Food chains are vital in the living world for two main roles: transferring energy and cycling nutrients through an ecosystem. Food chain plays an important role in the balance of stable ecosystem, and a disruption at one level can have a cascading effect on others. Humans, the miracle on the miracle planet. A human is a person, scientifically defined as a member of the species Homo sapiens, characterized by being a bipedal primate with a complex brain, the capacity for language, and the ability to create complex societies. Simple definitions include a person or a member of the human race. Modern humans are a very recent development in this long history, with our species appearing only about 200,000 years ago. Humans are very different from other living organisms due to their features. Human features can be divided into physical characteristics like bipedalism and opposable thumbs, and cultural characteristics such as language, social structures, and the built environment. Physical features are the biological traits of the human body, while cultural features are created by humans through their ideas, choices, and actions like buildings, art, or political systems. The human brain is capable of abstract thought, complex problem solving, and consciousness. Humans have less body hair compared to other primates, and visible genetic traits such as eye color, skin color, hair type, and height, or specific genetic characteristics like the ability to roll your tongue, have dimples, or a specific earlobe attachment. Earth's temperature is rising due to the human-induced greenhouse effect, primarily from burning fossil fuels, which has increased greenhouse gas concentrations like carbon dioxide and methane. This warming trend, with the last decade being the warmest on record, has led to significant consequences, including more frequent and intense extreme weather events like droughts, fires, and hurricanes, as well as rising sea levels and melting ice. Scientific evidence shows human activities are the primary driver of this warming, with the sun's energy output remaining constant or decreasing slightly since 1750. The planet's average surface temperature has increased by about 1.42 degrees Celsius, or 2.56 degrees Fahrenheit since the late 1800s, a seemingly small number that represents a massive increase in energy throughout the Earth system. The hottest place on Earth is considered to be Death Valley, California, which holds the record for the highest officially recorded air temperature of 56.7 degrees Celsius, or 134 degrees Fahrenheit. The coldest place on Earth is a high ridge on the East Antarctic Plateau, where satellite data recorded temperatures as low as -93.2 degrees Celsius or -136 degrees Fahrenheit. The average surface temperature of Earth, or global average, is approximately 59 degrees Fahrenheit, or 15 degrees Celsius. Earth's weather is a dynamic system of atmospheric events like temperature, pressure, and precipitation, driven by the sun's energy and occurring on short timescales. This weather is intrinsically linked to climate, which refers to the long-term patterns of weather over years and decades. The Earth's climate system includes the atmosphere, the air that surrounds the Earth, hydrosphere, oceans, rivers, lakes, cryosphere, ice sheets, glaciers, sea ice, lithosphere, land surfaces, rocks, and biosphere, living things and the ways they all interact. The 5 primary different types of weather that can occur are sunny, rainy, windy, stormy, and cloud. However, many of these types of weather can overlap and occur at the same time. Types of weather are influenced by sunshine, precipitation, wind, and humidity. Earth's weather features vary by region due to factors like solar radiation intensity, atmospheric circulation cells, and land/sea distribution, resulting in distinct climates such as tropical, dry, temperate, continental, and polar. These variations lead to differences in temperature, precipitation, wind patterns, and humidity across the globe, creating unique regional weather systems like the monsoon in South Asia and the jet streams that influence weather fronts. The world went through developmental revolution, with some extraordinary things. The wheel was not invented by one person but evolved from early tools likely in Mesopotamia around 3500 BC. The first wheels were solid wooden discs originally used for pottery, and an early version was found in modern-day Slovenia, dating back to around 5100 BC. A few hundred years after the potter's wheel, the axle was invented, allowing for the first wheeled carts and chariots. The electricity. Its development involved many scientists over centuries. Key figures include Benjamin Franklin, who proved lightning was a form of electricity, Alessandro Volta, who created the first battery, and Michael Faraday, who demonstrated electromagnetic induction, which laid the foundation for generators. Later, Thomas Edison created the first practical light bulb and power station, while Nikola Tesla developed the alternating current or AC system used today. The telephone. Alexander Graham Bell is credited with inventing the telephone, patenting his device on March 7, 1876. Though there is a dispute over the exact inventor, Bell's patent and successful demonstration of transmitting voice over wires were pivotal, with the first successful call made to his assistant Thomas Watson on March 10, 1876. Telephones convert sound waves into electrical signals, which are then transmitted and converted back into sound at the receiving end to make communication possible. Computer. The invention of the computer is a gradual process that spans centuries, evolving from mechanical calculators to the modern digital machines that have transformed and revolutionized every aspect of human life, including communication, business, science, and entertainment. Key developments include Charles Babbage's 19th century designs, the creation of the first electronic computers like ENIAC during World War II, and theoretical work by figures like Alan Turing on universal computation. The Internet. The Internet is a transformative technology that has profoundly impacted modern life, enhancing communication, providing instant access to vast information, and creating new avenues for education, commerce, and entertainment. It offers immense benefits by connecting people globally and streamlining daily tasks. Along with the benefits, responsible and mindful usage is essential to harness its advantages, while mitigating its drawbacks like addiction, scams, privacy concerns, and social isolation. Earth's resources are natural materials and energy sources, like water, air, soil, minerals, plants, and fossil fuels that humans use for survival and development. They are categorized as either renewable, that is, naturally replenished like solar and wind energy, or non-renewable, that is, limited quantities like fossil fuels and metals. Many resources, such as clean air, fresh water, and food from plants and animals, are essential for all living things to survive. Natural resources are used to create jobs and develop economies by providing raw materials for building, manufacturing, and energy production. Minerals and timber are used to make countless products, from machines to furniture and building materials. Fossil fuels have long been a primary energy source, while renewable sources like sunlight and wind are increasingly used to generate electricity. Mining is the process of extracting valuable geological materials from the earth, with the main types being surface mining and underground mining. Mining provides essential raw materials for construction, energy, manufacturing, and technology. It is a cornerstone of the global economy, supplying materials for everything from smartphones to wind turbines. Minerals are naturally occurring, inorganic solids with a specific chemical composition and a crystalline structure that form the building blocks of rocks, soil, and even essential nutrients for the human body. They are classified by their chemical makeup and crystal structure, and examples include gold, quartz, calcium, and magnesium. The Moon is the Earth's only natural satellite, a rocky body that orbits our planet at an average distance of about 239,000 miles and approximately 4.5 billion years old. It has a diameter just under a quarter of Earth's and was likely formed from debris after a Mars-sized object collided with the early Earth. Due to tidal locking, it rotates at the same rate it orbits, so the same side always faces Earth, and it takes about 27.3 days to complete one orbit. Moon has a rocky, cratered landscape that has remained largely unchanged due to the lack of an atmosphere and weather, making it a record of the solar system's history. The phases of the Moon are caused by its position in orbit relative to the Earth and the Sun. Phases are new moon, waxing crescent, full moon, and waning gibbous. The Moon is composed of silicate rocks, primarily oxygen, silicon, magnesium, iron, calcium, and aluminum. It has a layered internal structure, similar to Earth's, consisting of a solid iron-rich inner core, a liquid outer core, a thick mantle, and a crust, though the Moon's core is much smaller relative to its overall size. The surface is covered in a layer of dusty, rocky material called regolith, which is made up of fragments of rocks, dust, and glassy particles from impacts. So, we learned about our incredible planet, Earth, today, and I hope everyone has a better understanding about Earth now. We will discuss more interesting topics in the upcoming videos. Please make sure to subscribe my channel and don't miss any videos. Thank you.